From the earliest sparks of human curiosity about the skies above to the powerful machines that now pierce the heavens and carry humans and satellites into the vastness of space, the story of the rocket is one of imagination, trial, error, and extraordinary progress. Beginning thousands of years ago, when fire and propulsion were first harnessed in primitive but meaningful ways. For although rockets are often associated with modern science, their roots extend back to ancient civilizations where the combination of fire, gunpowder, and human creativity gave rise to the first forms of rocketry, with the earliest known use of something resembling a rocket traced back to China. During the Tang Dynasty, around the 9th century, when alchemists experimenting with mixtures of saltpeter, sulfur, and charcoal substances that together produced what we know as gunpowder, discovered that when this powder was confined within bamboo tubes and ignited, it could produce thrust. And though originally created for fireworks and ceremonial displays, this discovery of a controlled explosive reaction led to what were essentially the world's first rocket-like devices. And by the Song Dynasty in the 13th century, the Chinese had advanced the design into fire arrows, fitted with small rocket tubes that could propel themselves toward enemy lines, marking the birth of rocketry as a military weapon, a technology that eventually spread across Asia, the Middle East, and Europe through the Silk Road and Mongol invasions, influencing warfare and inspiring centuries of experimentation. During the medieval period, records from the Arab world reveal translations and adaptations of Chinese rocketry, with scholars and engineers in the Islamic Golden Age experimenting with gunpowder-powered devices. While in Europe, by the 15th and 16th centuries, rocketry was known through military applications, though crude and unpredictable. Yet by the early modern era, innovators such as Konrad Haas of Austria in the 16th century were already sketching designs for multi-stage rockets, foreshadowing ideas that would only become reality centuries later. And in India, during the late 18th century, the Kingdom of Mysore under Tipu Sultan famously used iron-cased rockets against the British East India Company, creating shock among European forces and inspiring further rocket development in Europe, where Sir William Congreve developed the Congreve rocket system, adopted by the British military in the early 19th century, giving rise to the rocket's red glare, immortalized in the American national anthem. However, despite these advances, rockets remained largely imprecise, short-range, and unreliable until the modern scientific era, when figures like Konstantin Tsiolkovsky in Russia, working in the late 19th and early 20th centuries, began applying mathematics and physics to rocketry, establishing theoretical foundations for space travel by formulating the famous rocket equation that explained how velocity could be achieved through the expulsion of mass at high speed. And his visionary writings suggested that rockets could not only travel through Earth's atmosphere, but even reach outer space, influencing generations of scientists. At the same time, pioneers like Robert H. Goddard in the United States took rocketry from theory to practice, conducting experiments that led to the world's first liquid-fueled rocket launch on March 16, 1926. In Auburn, Massachusetts, a small device that flew only 41 feet, but proved the principle of controlled liquid propulsion, a breakthrough that changed the trajectory of rocketry forever. While in Germany, Hermann Oberth published The Rocket into Planetary Space in 1923, inspiring young enthusiasts, including Wernher von Braun, who would later play a pivotal role in both wartime and space-age rocketry. The interwar and World War II period marked a turning point for the Nazis, seeking advanced weapons, invested heavily in rocketry, leading to the development of the V-2 rocket under Wernher von Braun's team at Peenemünde, the world's first long-range guided ballistic missile, capable of striking cities hundreds of kilometers away with devastating speed and power, representing the first man-made object to reach the fringes of space when test flights exceeded 100 kilometers in altitude. Though tragically, it was used in war against civilian targets. After the war, both the United States and the Soviet Union captured German rocket technology and personnel, sparking an intense technological race during the Cold War, with von Braun and his team brought to America under Operation Paperclip, where they contributed to the U.S. missile and space programs. While in the Soviet Union, Sergei Korolev emerged as the chief architect of rocketry, leading efforts that culminated in the launch of Sputnik 1 in 1957. The first artificial satellite, an event that shocked the world and inaugurated the space age, proving that rockets could carry payloads beyond Earth and triggering the space race. Just 4 years later, in 1961, Soviet cosmonaut Yuri Gagarin, aboard Vostok 1, became the first human in space, propelled by the R-7 rocket, a moment of immense symbolic and technological achievement, pushing the United States to accelerate its own space ambitions through NASA's Apollo program, which used the mighty Saturn V rocket, the most powerful rocket ever built at the time, designed under von Braun's leadership. And on July 20, 1969, this program achieved its historic climax when Apollo 11 carried Neil Armstrong and Buzz Aldrin to the surface of the moon, marking humanity's first footsteps on another celestial body, a feat entirely dependent on rocket technology. Rockets not only enabled human exploration, but also powered the placement of satellites into orbit, revolutionizing communication, weather forecasting, navigation, and global observation, embedding themselves into the infrastructure of modern civilization. While militarily, rockets evolved into intercontinental ballistic missiles, ICBMs, capable of delivering nuclear warheads across continents, shaping the geopolitics of the Cold War and beyond. The late 20th century saw continued development of both military and civilian rockets, with reusable spacecraft like the U.S. Space Shuttle relying on solid rocket boosters, alongside main engines to ferry astronauts and cargo to orbit, and rockets became increasingly reliable, though still extremely costly. In recent decades, a new era has emerged characterized by commercialization and innovation, as companies such as SpaceX, Blue Origin, and Rocket Lab have revolutionized rocketry with a focus on reusability, cost reduction, and frequent launches, with SpaceX's Falcon 9 demonstrating the unprecedented ability to land and reuse boosters, drastically cutting launch costs and paving the way for more sustainable space exploration, while its Starship system in development aims to transport humans to Mars, standing as the largest rocket ever built. Meanwhile, in China, the Long March family of rockets has advanced the nation's ambitions, placing takonauts into orbit and enabling lunar and Martian missions, while India's ISRO has developed the PSLV and GSLV series, positioning itself as a cost-effective space power. And other nations, including Japan, Iran, and North Korea, have advanced their own rocket programs, showcasing the global spread of rocketry. Today, rockets serve not only for exploration, but also for commercial purposes, such as deploying constellations of satellites for global internet coverage. And they remain the backbone of humanity's quest to expand beyond Earth, while future visions include nuclear thermal propulsion and advanced concepts like space elevators and alternative launch systems. Yet, as of now, rockets remain the only viable means to break free from Earth's gravity well. From humble fire hose in ancient China to reusable boosters landing upright on ocean barges, the history of the rocket encapsulates humanity's relentless drive to innovate, conquer challenges, and reach for the stars, transforming warfare, communication, science, and exploration, and continuing to shape the destiny of our species as we look outward to the moon, Mars, and beyond, where rockets will undoubtedly remain the vessels that carry our dreams into the infinite cosmos.